Hey friends, today we're going to look at 6.2, which is where we talk about multiplying and dividing radical expressions. This section is pretty difficult. There's just a lot going on. So we really encourage you to give us your undivided attention for the next little bit here. This video is going to be broken up into two parts, so make sure you take a break and follow along with us for the entirety of the lesson. So we're just going to jump right in to some definitions here. We're going to start with multiplying, and then we're going to work our way through to division. So, like I said in 6.1, it is going to be super helpful if you know your perfect squares, okay, especially when it comes to multiplying. So that's what it says first thing here. Knowing the perfect squares will help you simplify most of your radical expressions here. So you can simplify radical expression with the exponent of one factor of the radicand is a multiple of the radical's index. So it says here you can simplify the product of powers that have the same exponent. Similarly, you can simplify the product of radicals that have the same index. Okay, that was a lot. We don't even really need to get hung up there because what you need to know is highlighted down here in the green. Okay, if you have the nth root of A and the nth root of B, and you want to multiply them together, all you have to do is multiply the insides together, okay? The key here is when you are multiplying, you have to have the same index. So we're going to say the same index is required in order to multiply. Okay. The same index is required in order to multiply. So for example, right up here, we would have to say the square root of 2 times the square root of 3, that's equal to the square root of 6. Same thing here, the cube root of 4 times the cube root of 5, that gives you the cube root of 20. Since they have the same index, I can just multiply what's underneath there together. So let's put that into action here with problem number 1. It asks us, can you simplify the product of the radical expression, and then be sure to explain. On part A here, I'm going to go ahead and fill in my index there, and I notice that my index numbers are not the same, so this cannot be simplified. No, the product cannot be simplified due to different index numbers. On part B, we notice that we do have the same index number, so we actually can multiply them together. That would give me the cube root of -4 times 2. That gives me -8, and that can actually be simplified. As we looked in the last section, the cube root of -8 gives me -2. So if it can be simplified, go ahead and simplify it. That will help us out a lot. So on the bottom here, if you want to try to do these on your own, we encourage you to. Otherwise, you can go ahead and stay right here. The index numbers are not the same. Even though the radicands are the same, the index numbers are not the same. So we would say cannot simplify. But on part B, we can go ahead and simplify because our index numbers are the same. So that would give me the 5th root of 10, and there's no 5th root that goes into 10, so that is my final answer. That's kind of the easy part. This is where it gets a little bit harder. It says here that if you can reduce the radical, you have to reduce the radical, okay? So, for example, if you have the square root of 24, we know how to break that down. That breaks down into the square root of 4 times the square root of 6. We know the square root of 4 gives me 2, and then I can't take the square root of 6. So in Algebra 2, we go from here to here, and you should be able to follow along with that. Now we do the same thing for the cube root of 24. Except instead of looking for the perfect square factor that goes in, we're looking for the perfect cube factor that goes into 24. So the perfect cube factor that goes into 24 is 8. So we would say the cube root of 8 times the cube root of 3. And we know the cube root of 8 is 2. So that goes to 2 times the cube root of 3, which is what we got right here. So, moral of this story is you have to be extremely careful as to what index you have. Whether you're taking the square root or the cube root, you're going to get two totally different answers. So you just need to make sure you are reading and paying attention. So we did a couple of these back in 6.1 because I knew what was coming. But we should be able to handle this pretty solidly with problem number 2. It says, what is the simplest form of the cube root of 54x to the 5th? So again, I always break down and separate my number from my variable. I always do that first. And then from here, we're going to say, okay, what perfect cube factor goes into 54? We work with this all the time. The perfect cube factor that goes into 54 is 27, so that gives me 27 and 2. If you don't remember how to find the perfect cube factor, if you go to y equals, and if you want to type in 54 divided by x, and then you go to second graph, that should bring up the table, and you want to look in the y column to see that it is in fact 27. All right, so then that simplifies to 3 times the cube root of 2. So now that's simplified all the way. I can look at my variable here and ask myself, how many times does 3 go into 5? That goes in 1 time with 2 left over, because 5 minus 3 leaves me with 2. So I have 2 underneath the radical here. So now I can write my final simplified answer, and I'm going to write everything on the outside of the radical together, and then I'm going to write everything under the radical together. And there we go. We have to talk about the simplified form before we start multiplying, because once you multiply them together, then you're going to have to simplify it even further. So that's why we're taking kind of a side step here, making sure you know how to simplify. So let's look at this next one and make sure that that radical, like it goes all the way over. And we're going to start off the same way we have been. We're going to break everything apart. I have the cube root of 128. I have the cube root of x cubed. And I have the cube root of y to the 6th. Now again, dealing with the cube root, we want to look for the largest perfect cube factor that goes into 128. That would be 64 and 2. So that would simplify to the cube root of 64 is 4 times the cube root of 2. Moving on to my variables now, 3 goes into 3 one time, so that just goes to x. 3 goes into 6 2 times, so that just goes to y squared. So I can write my final answer, everything on the outside of the radical together, and then everything inside the radical together. And I think that was all. If I lost you anywhere, it might have been in the simplifying part right here. I have taken the time to memorize my cube roots, so I know the cube root of 64 is 4. But if you need to go back to the if you need to go back to the calculator, if you go to math, and if you want to take the cube root of 64, you would get 4. Okay. I think we're ready to start multiplying, so here we go. We're going to simplify this product because it asks us what's the simplified form of the multiplication here. So you notice you have the same index, so you know you can go ahead and multiply them together. So let's go ahead and do that. If I'm going to multiply these two together, that would give me 720 x to the 4th, because there's one of them right there, and then y to the 5th. When you are multiplying, you add the exponents together. So that's where I'm getting the 4 and the 5 from. So since I've multiplied those together, I can go ahead and break down my number and my variables. And just be extra careful here, friends. The last couple have been the cube roots. This one is dealing with the square root. So that's a big number, 720. I have no idea what that is off the top of my head. So let's go to the calculator and go to y equals, and let's do 720 divided by x. And then we're going to hit second graph. And we're going to look in the y column after 0. And it looks like my largest perfect square factor is going to be 144. So I'm going to use that here and say that simplifies to the square root of 144 times the square root of 5, which gives me 12 square roots of 5. I can go ahead and simplify my variables here. That would give me x squared. Here, 2 goes into 5 twice with 1 left over. So I can write my final answer as 12x squared y squared times the square root of 5y. I don't have to put the 2 in the index. You can if you want to, but remember, if you don't put it there, it's understood to be the square root. Please, please, please make a note if you have any questions. We would love to answer them during office hours or maybe during a Teams meeting. But in the meantime, let's try another one. We'll do 2 more and then this will wrap up part 1. So on this first one here, you notice that your index is the same, so we can go ahead and multiply. That gives me 2400 x to the 7th and then y to the 6th. Okay. So now we want to go back to our calculator and let's do 2400 divided by x. X. And then we can go to the second table and let's look in the y column, and we notice that the square root of 400 is 20, so it looks like 406 is what this is going to break down to. But let's go ahead and take a second and break apart all of our numbers from our variables, and let's rewrite that. So that'd give me the square root of 400 times the square root of 6, which gives me 20 square roots of 6. Remember, 2 is your index, so 2 goes into 7 3 times with 1 left over. 2 goes into 6 3 times with none left over. So we would say our final answer here would be 20x cubed y cubed times the square root of 6x. The key to success here, guys, is knowing your perfect square factors. So let's go ahead and try one more. If you want to pause the video and see if you can try this one on your own, that would be fantastic. If you're still a little hesitant, just stick right here with us and do what you can. Maybe pause as you go. So the first thing we're going to do is multiply. 45 times 35 gives me 1575. And then that would give me x to the 6th, y to the 7th. So I'm not going to skip a step here. I'm going to go ahead and break apart my number from my variables. And again, we are dealing with a square root problem. So we want to look for our perfect square factors of 1575. So let's type in 1575, and we're dividing that by x. And we're going to go to the table. And it looks as if 225 is going to be our perfect square factor. 225 is the perfect square here because that breaks down to 15. The square root of 225 is 15. So we're going to say that's 225 times 7, which simplifies to 15 square roots of 7. And then again, we can simplify the variables here. That gives me x cubed. 2 goes into 7 3 times with 1 left over. So if we're going to write our final simplified answer, we're going to say 15x cubed y cubed times the square root of 7y. So again here, friends, the key is knowing your perfect square factors. If you need to make a list, make the list, okay? Go ahead and make that list. This is the end of part 1. We'll pick up with part 2 with division, but please make sure you are taking excellent notes and making sure that you jot down any questions that you may have that you want to ask us during office hours.